Cool. So today, the actual demo part of this, we will be running through how to run a Vega validator node. So if it'll be kind of an interactive-ish session. So if you'd like to follow along, you've got a few minutes now while I talk through a few bits. So feel free, if you've got access to a VM or a server that you can run a node on. There's some stats there that, or some specifications there that we'd kind of recommend. You should probably get away with 2 cores and 8 gig, and an Infura account. So we can link that so you can see the Ethereum events. So while I'm running through this bit, if you'd like to do that and get set up, you can follow along when Pete and the other guys run through that part of the demo.
Magic. So this part's going to be Candida and myself discussing about validators. So I'll pass over to Candida first.
Thanks, Pete. Hi, everyone. As Pete said, my name is Candida, and I work on the documentation for Vega. So Pete is going to be using our documentation, which is on the website you can see on the screen right now, to demonstrate setting up a validator node on the Sandbox network. Sandbox is a testnet environment specifically set up to try out the validator node process. So there's not really like a trading console or anything like that on there. It really exists for, in effect, the demo that Pete is going to do today. Edo, if you haven't already, would you mind sharing a link to the docs in the Twitch chat so people can follow along? Thank you. So while we hope the instructions are fairly easy to follow, as is the demo, it's worth noting that setting up a validator node, as you can see by the big danger box on the screen, setting up a validator node is geared towards people with system admin and development experience. So it's not necessarily a beginner task. Running a node, a validator node specifically, will require keeping it running and maintaining it. And that's especially true, obviously, for mainnet. Whereas Sandbox, this network that we're going to be using today, is a great place to try it out with no risk, see what the process is like, and get comfortable with it. So before we carry on, I'm going to quickly describe the 3 tiers of validator nodes on Vega, just so you have a little bit of background at what's going to happen. So the lowest tier is a candidate node. So when you first set up a validator node, your node is considered a candidate node, which is also described as pending in the API. So if you see something listed as a pending node, it's the same thing. Candidate validators are either not fully set up, they haven't been taking part in the network for long enough to be promoted, or they have done all that, but all the other slots in the higher tiers are filled, so there's no room for them to be promoted out of candidate. And candidate nodes do not take part in consensus. The tier above candidate is standby, also called ersatz in some places. Those validators are on standby, as it were, for a consensus slot to open up. Standby validators can be promoted to be consensus validators if they have enough stake and a good enough performance score to overtake if a consensus node performs poorly or leaves the consensus validator set. Standby nodes do not take part in consensus either. And then finally, you can probably guess consensus is the top tier of validator nodes. They take part in validating transactions and reaching consensus to create blocks. And so they are pretty integral to the functioning of the Vega network. So that's a fairly high level overview, and there's a lot more detail about how they get promoted and demoted and whatnot, but I'm going to leave it there for now, or we'll be here for the whole afternoon. So in the demo that Pete is about to do, we probably won't get a chance to see a node go from all the way from candidate to consensus, because some of those steps require waiting for an epoch to turn over, and we just don't have that much time. But Pete is going to walk through the process of setting up the node software and then taking it through the steps to be accepted as a validator node that can then take part in the network. So with that long intro out of the way, I'm going to pass over to Pete now.
Thank you very much, Candida. So we have the documentation, which splits installing a validator into 3 parts. The initial setting up of the server and building the software, configuring the components, and then joining your validator to the network and validator set. So we're going to go through those one by one. We're going to assume that you've got a brand new VM, you've got nothing installed, and go from there. Right, so if I bring up a console, so I've just got a small computer sitting next to my router. It's got Ubuntu installed on it. I've just checked that it's as upgraded as I can get it. The first thing we need to know is, does it have Git installed? I think this is it's installed by default on most things. You can check by doing Git version. If you need to install it, it's as simple as a sudo apt install Git. Next step is we need to have Go installed. So I've already got it because I've been using any version 1.19 or upwards is good enough. If you do need to get it, you can just use these commands to download the executable from the website. And then once you've downloaded it, you can just install it using this. So this just stores it into your user local directory. Hopefully you've all got this already. If you haven't, then you need to do this. It only takes a few seconds. If you find these instructions difficult, if you go to Golang website, it will tell you exactly how to install things for Linux. Once you have it installed, there's a couple of environment variables we need to set. On my machine, I have a directory called Vega. So just like this, that I'm going to place all of my files and objects in. So I'm going to set my Go bin to point there so that every time I build something, it will place it into that folder. Okay, so once I've got source code down and I build it, it will go into that place. The last thing we need to set is to tell it not to use any CGO modules, sorry. So we just turn that off by doing this. The last piece of software we need to install is an application called Geth, which we're going to use for doing Ethereum accounts. That can just be got down because it's a Go application by using this command. So if you do a search online for Geth, you'll find information about it on GitHub. If you just do this command here, I can do it now, it will go off and get the latest version, which I should already have, and install it on your machine. So we're good to go. This isn't the fastest machine. Well, there we go. So I now have Geth. So if I type Geth version, I have that installed. Great. So now the machine's set up, the next thing we need to do is actually get the source code out. So if anyone that's looked at the Vega repos before will know that we have a Vega repository, which if we can probably have a look, have I got it here? Yeah, so this is just where we store our source code and it's publicly available so anyone can have a look. We're just going to pull that down in the clone. I've created a directory called Sandbox to put my source code in, so I'm going to clone that now. This takes 30 seconds or so, depending on your internet connection, and gets all the source code we need for building Vega, for later building the data node, and for building Vega Wallet. So if I had the internet that was being installed at Gordon's house right now, this will be done in 5 seconds, but mine's a little bit slower. And for anyone that's following along, this gives you a little while to catch up, I hope. Okay. We're done, brilliant. So we should now have a directory with all the source code for the Vega application. To get a particular version, we just do Vega checkout. We're going to be using version 6.1, which matches the documentation. So if we go back to the documentation part, you'll see up here we're doing the documentation for 0.66. There we go. So we've now moved to that state. Brilliant. And to build it, it's as simple as doing this. This goes off, pulls any dependencies, modules that we need down from the web, builds them all, and then builds all of our source code. If we're looking at the instructions in the documentation, it does it slightly differently. So it only builds the Vega application. But for me, it's easier just to build the whole lot because we might need them later on. Okay, so this will take probably a minute or two. Let's have a look at what's next. oh, this is it for the first part. So once this has built, we can check that it's built and it's installed by seeing what version it is. Okay, so there we are. We've now got a Vega, and we checked its version, and it's the one that we've downloaded. Brilliant. So if we're back to the documentation now, we've done all of the first part. We've now got our executable. That was the easy bit. So next stage is setting up the Vega software. So the Vega software consists of two parts. It's Vega and Tendermint at this level. So a lot of this configuration will be setting up Vega and Tendermint to talk to each other so they know where their endpoints are, and to set up the keys they'll need to communicate and to do things with the network. So the very first thing we have to do is just initialize everything. This will create a set of folders and configuration files that we can start. If I go here. Right, as I said before, I'm using a Vega folder. So everything that's to do with Vega is going to go into /Vega/Vega. Everything to do with Tendermint will go /Vega Tendermint, just so I can keep the config files apart and know where to look for them. And into a password. Spell it right. There we go. Let's make that a bit wider. During this demonstration, a lot of my passwords will be visible. That's just so that you guys can see what it's doing. There's nothing you can do bad to me, but will hopefully help you guys learning to know what I'm doing. So this is the first part. I've now created the configuration files. We can have a quick look where they are. There we go. So we've now got a Tendermint folder and a Vega folder. Just go into Vega, have a quick look. It's just created all the config files we need for this node that we'll be able to edit with the details that we're about to get. Right. So as we said earlier, we need Tendermint to talk to Vega. So we need to go and find out in our Tendermint folder what's the address that it's listening to for its RPC connections. So if we just follow those instructions, right, nano, Vega.
Hey, Pete, could you make your command window just a bit bigger so we can get a bit more history on there?
Oh, taller. Okay, yeah.
Yeah, taller, exactly.
How's that? Is that okay?
Yeah, cheers.
Right, so we need to edit. Oops, sorry. Tendermint config. Right, we're going to look in here and find out where its RPC address is. We could search for it, but it's here. So this is the address in which the Tendermint's listening to. So we just need to copy that out for now. And then I need to go into my Vega config and update it. Vega. Okay. And in here, there should be a blockchain section. And in there is an empty RPC address. And we plug that into there. Save that. And then the next step is to do with Infura. So Infura gives us the ability to listen to Ethereum events. So hopefully you guys have set up an Infura account. If you haven't, I can just step you through how easy that is. If you just go to infura.io, you can register with any email you want to. So I've just done my work one here. I'll log in. And it gives you an option of creating a new key. If you just choose a Web3 API, name it anything you want. I'm not actually going to hit create because I've already done this earlier, but this is all I did. I just went to Web3 Sandbox and hit create. It then creates me these keys. And the important thing you want from this is this magic part here. This is the API key you're going to need. So when we go back to our console, we're going to edit our Vega console. We're going to Vega command. In here is going to be a section about Ethereum. It's all sorted out alphabetically. There we go. There's an RPC endpoint. So we just need to tell Vega where to look for to get Ethereum events. In there, we put followed by our API key we had. So I'll just leave that for a bit. So the Sepolia.infura.io part is just their API endpoint. And by putting your API key at the end, it just allows you to access it and get the Ethereum events you need. Okay. And saved. So now we've got the parts talking to each other. The next thing to do is to create some wallets. So we need a Vega wallet so that we can store Vega tokens and other things that a validator needs. The Vega application has the wallet commands built in. We can just type Vega wallet like as such. And we just create a wallet. And I learn to copy. Just like this. So you just give yourself a wallet name, whatever you like, and tell it where you want to keep these folders. And sorry, cut and paste.
Pete, be careful. You forgot a dash in front of the home flag, which might create your
Thank you.
in a different directory.
Okay, let's just do that again then. There we go. There's some really important things in here. Normally, when you do this yourself, you wouldn't share your recovery phrase with anyone because they get access to your Vega account. But for me, this is just practice, so it doesn't matter. But we will need this later because we're going to be importing this into the desktop wallet. So when you do this step, make sure you cut this and paste it somewhere that you can keep it. And this should have created inside your Vega folder wallets. Yep. And this is where your, here we go. And it's put quotes around it just to be very annoying. So this will teach me to cut and paste things from a Word document. It's used funny fonts everywhere. Okay. When we access our wallets, we use a password that I just typed in there. It's often easier to put that password into a file that we can then just redirect in. So that's what I'm going to do now. So I'm just going to do one called wallet password. And here I'm just literally going to type password that I typed in before. Now, for the Vega application to know that this Vega key is mapped to it, we need to import it. So the next thing we're going to do is import that key we just had into Vega. And I'm scared this is going to do everything. Oh no, it's done all the double hashes this time. It hates that, doesn't it? Let's move that. Try that again. Brilliant. So Vega now knows about that Vega wallet I created. I'll just give you a few seconds, make sure you've caught up. Okay, the next section is to do with Tendermint again. So Tendermint has its own public keys that it will use for signing things, and we need Vega to know about those as well. So we need to go into the Tendermint configuration and find out what the public keys are. Let's have a look. So inside those Tendermint, there's a config folder, and it has our private validator keys. Again, this is something we don't really want to be sharing, but now because we're practicing, it doesn't matter, we're going to share it. So we're going to look for the public key. It's the one here. I'm going to grab that out. And we're going to go and import this in to here. All of these commands are in the documentation in the steps we go through. So if any of these I'm going too fast, you can just look at the docs and they're in there. Okay. So that's now a Vega key we have. We've done the Tendermint key, and now we just need an Ethereum key. And this is why we installed the Geth application earlier. So Geth's used for handling Ethereum. It can handle the blockchain, it can handle the accounts. For us now, we're just using it for the accounts. So if I just tell it that we want to create a new account, and we tell it where it's going to store its key values. So again, it's in my Vega folder. There we go. And the thing to notice here is where it keeps your secret file. So it's putting in my Vega, Geth keys, and then a very long file name describing what this Ethereum account is. And so to import that into Vega, it's very similar steps like we had before. Let's look. Sorry, just cut and pasting. There we go. And then we just put the name of the file we just created in here as well. Oh, what have I done? Oh, can't paste again. Brilliant. So now we've got the 3 keys in. Now the more fun part where we're actually going to start talking to the Sandbox network that's already running. So we want to start our node up, and we don't want to replay all the chain, because at the moment there's about 400,000 blocks, and it will take 4 hours to replay that. So we're going to start using the snapshot functionality. So we're going to join the network, and we're going to ask them to give us some snapshot stuff to prevent us from having to download everything. So we're going to look at the Tendermint configuration. First thing is we need to point it at the current network. So if I just do a search for persistent, right, there's an option called persistent peers, and this is where you tell Tendermint which other nodes on the network you want it to talk to. If you go to one of the existing machines on the network, so here I've gone to N02, which is one of the Sandbox machines, you can get its ID just from this description here, and its location is the listening address. So if you go through more than one machine, so you can go to N02, N03, N04, we've got 6 machines, I think, you can scrape this data out and you can build yourself a set of persistent peers, which you can add to this part here. If I go back to here. There we go. So I've just added a long list of, I think it's maybe 5 of the peers that we have into that persistent peers section. And while we're in here, there's 2 other things we have to look at, and that's a max packet size. And we need to make this a little bit bigger. I think this will be changed by default in later versions, but for now, we just have to make it that, and that should be it. One of the parts of using snapshots is you need to tell the software which snapshot number you want, or how many blocks in you want to start reading snapshots from. So if we go and have a look at the statistics for the current running network, we can find out what the current block height is. So at the moment, it's almost at 500,000. So this is how many blocks we've handled since the Sandbox network has been live. And we also need the block hash, which is at the bottom. And that's just where guaranteeing the block is the one that we want. If I go back into the config now, there should be a section called state sync. Oh. I'm the wrong one. Config. I spelled it wrong. My fault. State sync. Here we go. And this is where we tell it that we want to use snapshots. So we go into here. True. We go back to our web page and we find out what the current block is. We'll use this one. And then we grab the hash from that as well. Yep. And I think that should be, oh, I might missed one more. I need on PC server. We need to tell it what machines to ask for the snapshots from. So you can pick any of the N0 machines that you have. And we can just post that in there. There we go. That's now everything that it should need to start up. So now the last command we need to do is to tell it to actually start. So the options we're given it is just saying where all the Vega information is held, where the Tendermint config is held, and then we point it at the Genesis file, which is stored in GitHub. So I'm just pointing out the raw version of the Sandbox. If you go to the network internal repo from Vega, it has this information in, so you can get this if it changes. So I'm hoping this is going to start and we're going to have a validator connect and it will start doing its magic, discovering new snapshots. And there we go. So it's now caught up, it's loaded a snapshot. So we're now running a validator that isn't quite a validator yet. So it's acting like a non-validator, but it's on the chain, it's getting all the blocks, and it's doing all the processing it needs to do. So that's from the documentation, that's all the configuring the components part. So now the bit that's left is joining us to the network. Right, then let's have a look. So for this, as I said earlier, we're going to need to run the desktop wallet. And that's because we're going to be doing this through a browser. So all the parts we did before was just through a console window on a server, but this part we're going to be doing through a web browser. So you're going to need to go to another repo, the Vega Wallet desktop, and inside releases, we're going to get the latest one. And I'm on Windows, so I just downloaded the Windows zip file. Inside that's just an executable. And when I double click that, sorry, I'm just going to drag this onto the screen so you can see it. Here is the desktop wallet. And for this, we're going to use the recovery phrase that we had earlier. We're going to create a wallet. There we go. Password. And we're done. Good. So now we have a wallet. One thing this wallet hasn't set up for is it's not connected to the Sandbox. So that's one thing we're going to do. We're going to import a new network, add network. Again, the information for this is stored on GitHub. It's in the documentation, and we just point. There we go. So what this is doing now is it's going off to find all the information it needs about that network. So who it can send things to, trades to, where it can find out queries from GraphQL. Hopefully, should have imported. Great, so we now have a network. Brilliant. And now that means I have a Vega wallet running locally on my desktop that's connected to the Sandbox network, and it has my wallet in it, my Spuddy wallet. Next step is MetaMask. So MetaMask is what we're going to be using for our Ethereum stuff. Well, so I've just gone to a browser, I've typed install MetaMask. Install MetaMask for Edge. Apologies for using Edge. I don't know quite how it's happened, but it's working. There we go. Hopefully you've all used MetaMask before. This is the standard stuff we have. We're going to create a new wallet. Cool. Do the next. Don't care about my recovery thing. Here we go. Now, the important thing is the Sandbox is running on the Sepolia network. So we need to make sure that we have the test network set on for this. Then I can go back and there'll be the Sepolia test network, and that's what we're going to be using. If we're going to do any transactions, we need to have some tokens on this network. And there's a faucet that I found on the web, which we're going to use. So what I'm going to do is I'm going to grab my address. I'm going to go to here. I'm going to ask it to just generate me some quickly. So this is just a free service, and it just lets you grab a couple of Sepolia Ethereum tokens that you can use to pay for your transactions. So I just give this 30 seconds. So now we have our tokens. So we're going to go to the smart contracts now, and we're going to faucet some Vega tokens that we can use for voting and proposing and other things. Let's go here. Okay, so this is the token website that we're using, which I was doing. And now we're going to go to the contract. And we're going to go to the right contract here. And we want to faucet some tokens. First, need to connect to MetaMask. That's me. Right. Go to faucet and we write. So this is going to give us 3,000 Vega tokens that we can use for proposing us as a validator. That's gone. We go onto here and we just check that that's gone through. Good, that succeeded. Now we go back to this. We're going to go to the validators page, and we're going to connect this to our two wallets. So we've got our Ethereum wallet, which is built into MetaMask. There we go. We can see we've got the 3,000 Vega, and then we're going to associate it to our Vega wallet, which is our Vega desktop wallet. I probably have to go back to Vega wallet where it says, are you sure? You go, yes. Right. Brilliant. So here we go. So we've got our 3,000 Vega tokens. We're connected to our Vega wallet. And so now what we have to do is associate these. So we click on the associate button. We say how we want to use. We want to use all 3,000. And then we say, yes, we'd like to approve them for staking. This goes back to MetaMask and gets our approval. We go, yes. This usually takes about 20, 30 seconds. We're just waiting for the approvals to go across the Ethereum network. I have no idea if the Sepolia network is faster than the normal Ethereum network, but it seems to work. Brilliant. And the next one is to associate those tokens with a key on our network. Oh, there we go. And again, it's another MetaMask thing. Once this is complete, it's basically meant we've had 3,000 Vega tokens that we've now associated with the node software that we're running. And we can then use that when we propose to be a validator. So when we announce to the network, hey, we'd like to be a validator, it will check and say, yep, you've got the minimum amount of tokens we need, which is 3,000 to become a validator. So that just removes that hurdle. If you don't have enough Vega tokens, so you've only got 2,000, you won't be able to be a validator. If you have a lot more, you can, but 3,000 is the current minimum cutoff. Okay, one more confirmation, so that's nearly done. Finally, if I hit refresh, sometimes it just works. Let's have a look. Yeah, I think it's associated, everything's done. Brilliant. So now back to validators again. So interesting to look on here is what current epoch you're in. We're in epoch 168. So when we go to do the announcing, which is the very last part of us saying to the network, here's what we want to do. Just need to get another browser up. Oh, let's make that bigger so you can see it. Right, this is the last command we need to run, and this is announcing the node. So this is telling the network that we want to be a validator. So we can give it some names. Epoch from was 168. And my submitter address is my Ethereum address that I store things in. So it's back to MetaMask. I'm grabbing here. Hopefully, that's everything. Missing required announce node fields. Okay, so I guess you need to populate these with everything. So this one. Okay, it's done it. So at this point, we've announced to the network that we want to be a validator. And I'm hoping it might not be yet because we've got to wait for this epoch to end. But as soon as this epoch ends, we'll be part of the validator set. We probably won't be one of the active validators because I think there's only 6 as a limit, but we'll be one of the ersatz ones that's waiting, saying if any of the 6 fail, we can jump in and take their place. I don't think we're going to see ourselves on here. No, not yet. I think we have got to. Oh, here we go. I'm a candidate. There you go. So now I'm a candidate validator. So if you were following along, hopefully you'll get to this stage as well. And once the epoch ends, you'll probably move to maybe a standby one. And then if any of the main ones fall out, then you get to be one of the consensus validators. At this point, I'm finished. So well done, anyone that followed along. I'm a validator. I hope you lot are as well. I'll pass back to Candida.
Great, thanks very much, Pete. Before I move on, I'm just going to throw it to Edo and ask if there are any questions in the chat.
No direct questions on this, Candida, but thanks for asking.
Cool. Okay. So thanks everyone for watching the demo. I'm going to ask you all now to check out the docs for more information on validator nodes and the Vega protocol in general. And if you have any trouble starting a validator on Sandbox, you can always ask for help in the Sandbox support channel on Discord. And if you have any feedback on this or anything else related to the Vega software, you can always leave feedback on our feedback discussion board at github.com/Vega protocol/feedback/discussions. And I'm going to ask Edo again if he doesn't mind putting that link in the Twitch chat for everyone. And then I think that's, oh, sorry, Gordon, did I steal your thunder on that one? Thank you. Perfect. But yeah, I think that is it for me and for us, unless anyone has any questions.